Hey everyone, welcome to Particles in Motion Part 3. This is Nicholas JMV. Today we're going to be determining where a particle slows down. Okay, so here's our example. Now we're going to use the same examples we did in the previous video. So if you haven't watched the previous video, you might want to, because I'm going to just be writing a few things. We want to know when the particle is slowing down. So that means we want to know v of t, velocity, and a of t, acceleration. When do they have different signs? That's the big thing here. That's when a particle slows down. That's how we know it slows down. So what I did from before, let's go ahead and look. We know that x prime of t, and this is from the last video, okay? X prime of t is equal to 3 times t minus 6 times the quantity t minus 2. And I know that the second derivative is x double prime of t is going to be 6t minus 24. Okay, so if I set both of those equal to 0 like I had to in the last video, I have the following solutions for t. I get t equals 2 and t equals 6. And then here, if I plug in 0, I'm going to go ahead and factor this really quick. I had t equals 4. So I'm going to set up two sign lines to do this, and then I'm going to try to simplify from there. Okay, so let's go ahead and look at the two sign lines. Okay, so I'm going to have t minus 6, t minus 2, and x prime. What's x prime of t doing? Okay, so here's my sign line. And then 2 and 6. And then sign line to 4. Pretty easy. Let's just start with the second derivative because there's only one term. If I look at any number greater than 4, you're going to have a positive result. Because a positive times a positive. Anything less than 4 is going to give me a negative quantity. It's going to give me a negative. So that one's pretty easy. Sign line here. Anything greater than 6 is going to give me something that's positive. Anything less than 6, this quantity is going to be negative. So if I plug in 5 minus 6, okay, so I plug specific numbers in here. T minus 2. Numbers greater than 2 is going to give me something that's positive. Anything that's less than 2, this little quantity becomes negative. So anything greater than 2 is positive, and then this is negative. Now, because this is multiplication, I need to multiply here. So two negatives make a positive. Opposite signs, multiplying, you get opposites. Okay, and two positives here, you get positive. Okay, so perfect. Now I'm going to put all of this together. Okay, and you can do this by interval. Okay, so we're going to start. So time, okay, velocity, acceleration. Okay, we're going to go from 0 to 2 seconds. Okay, I would go to 6 seconds on the next one, but 4 is important here. So we're going to go between 2 and 4 seconds, 4 and 6 seconds, and t is greater than 6. And now we can just fill out our sign lines. Now let's look. First derivative. Anything, so greater than 6 is positive. Okay, so we have plus here. Okay. Between 4 and 6, we have, look, 4 and 6 is somewhere in here. It's minus. Okay. Between 2 and 4, 0 and 2, this is positive, right? Right here, between 0 and 2, and between 2 and 4, okay, 2 and 4, that's also going to be negative. Okay. My acceleration, hey, anything greater than 4 is positive, right? So positive, positive. Anything less than 4, negative, and negative. Now, looking at that chart, where do you see the values that are going to be opposite signs? Velocity and acceleration, right here and right here. Those are the two intervals in which the particle is slowing down because the velocity and the acceleration have opposite signs. So what I did is a sign analysis here. It gets a little more tricky. Okay, I did a sign analysis for the first and second derivative and just kind of pieced it together here and looking for signs that are opposite. So if you have any questions or comments, let me know, and we'll see you next time.